time that you see the zapper initiate the zapping.
Missiles traveling near the speed of light deliver massive blasts without the aid of explosives.
It starts to become possible to hit things with the energy of an atomic bomb without actually having to use any sort of radiation.
And space pilots battle to the death in a very different kind of dogfight. These aren't just sci-fi fantasies. They are the future of space wars in the universe. It's 100 years in the future, and the final frontier has turned into the ultimate battleground. A rogue colony on the moon has already attacked neighboring colonies. A spacecraft from Earth has moved into position after negotiations have broken down.
As we travel out into the solar system and maybe even the stars, there are going to be people who disagree with other people, and the potential for warfare is just as great there as it has been any time through human history.
Before the rogue colony takes any more innocent lives, the spacecraft releases a weapon of unimaginable power, an antimatter bomb. Antimatter is the same as normal matter, except with the opposite atomic charges. Instead of negative electrons and positive protons, antimatter has positive electrons and negative protons. When matter and antimatter touch, they instantly annihilate each other, releasing a huge amount of energy.
When you have antimatter colliding with matter, all of the mass gets converted into energy. 100% efficiency. That's a lot of bang for the buck. Even nuclear weapons are only about 1% efficient. Chemical weapons are a tiny fraction of a percent in terms of their efficiency.
A warhead of normal matter would simply explode when it came in contact with the antimatter inside. The antimatter bomb streaking toward the rogue colony is a mass of antimatter surrounded by an electromagnetic field. Just before impact, the field is turned off.
You don't even need a fuse, you just need that antimatter to reach the desired destination and hit it. And it will then convert all of its energy and the energy of the object that it hit into this explosive energy, producing a tremendous explosion.
Other spacecraft in orbit around Earth target smaller remote outposts loyal to the rogue colony with powerful laser weapons.
An advantage of a laser weapon is that the laser beam travels at the speed of light. So you could have these light beams going across very large distances in a very small amount of time, zapping the enemy before the enemy realizes what's going on.
Light races across the universe at 186,000 miles per second. So the futuristic laser weapons fired from orbit near Earth take just over a second to blast holes in their targets on the moon, about 240,000 miles away. But just because we're 100 years in the future doesn't mean simple projectiles have disappeared from the battlefield. They inflict damage by slamming into the enemy, using what's known as kinetic energy, the energy of motion, to destroy a target.
If we accelerated some kind of mass up to sizable fractions of the speed of light, wouldn't even need a warhead. Just the kinetic energy of the motion of that object itself would have an incredible destructive power.
Like an asteroid impacting a planet, the more an object weighs, its mass, and the faster it's going, its velocity, the more kinetic energy it has. But velocity has an advantage over mass in the kinetic energy equation, since mass is multiplied by the square of the velocity.
So something traveling twice as fast has 4 times the kinetic energy of something of equal mass. So you get something up to very high velocities, it has a lot of kinetic energy.
The different amounts of kinetic energy are easy to see when hitting a target with the same type of projectile traveling at two different speeds.
This firearms expert is going to fire two identical lead balls. The first from this smoothbore pistol. The second from this smoothbore musket. Now, with its longer barrel and larger powder charge, it's going to fire that ball much faster. Let's see.
First, the pistol sends the ball down range at a relatively slow speed. Now, the musket fires the same sized lead ball at a higher speed.
On the back of the target, you can see the damage caused by the lead ball fired from the pistol. But now look at what happened with the lead ball from the musket. Much higher kinetic energy, much greater damage.
And out in the vacuum of space, there's no atmosphere to slow things down. So another ship in Earth orbit launches a telephone pole-sized projectile made of dense metal at the rogue colonists' underground headquarters. It's known as a rod from God. After a brief rocket boost, the acceleration of gravity gets the non-explosive rod moving at more than 10,000 miles an hour by the time of impact.
As we're able to get heavier and heavier objects moving at faster and faster velocities, it starts to become possible to hit things with the energy of an atomic bomb without actually having to use any sort of radiation.
The heavy metal rod penetrates layers of moon rock to destroy the underground command center. Without explosives, kinetic energy alone has devastated the area. Like an asteroid, creating a huge crater. But no matter how advanced space weapons become, one of the basic principles of warfare and technology will probably still apply.
I think it's an inevitable fact of human nature and human history that the invention of one weapon and its use triggers a countermeasure or a way to try to defeat it or build a better one. So you're going to see that in space weaponry no matter how far in the future you go.
A fantastic countermeasure against a directed energy weapon like, say, a laser would be a cloaking device like we see in many science fiction shows like Star Trek. If we can render a ship invisible, then electromagnetic energy just passes right through it.
But the technology to make entire spaceships invisible, or the power needed to create lasers strong enough to blast big targets from vast distances, are well beyond our current capabilities. And right now, there aren't any offensive weapons stationed in space. But war could still come to space within the next decade or so.
The future of space warfare may look a little different. At first, I think it's going to be satellites and anti-satellite systems, missiles and satellites, not manned systems at all.
And why would satellites, and the weapons that can destroy them, likely be the focus of the first space war? Because satellites are already essential to fighting wars on Earth.
America, in particular, is extremely dependent on space. Our military cannot operate the way it does today without satellites. We use them for communications, navigation, intelligence gathering of all kinds, whether it's photo intelligence, whether it's signal intelligence. A lot of it is done by satellites. Even ground maneuvers require very accurate positioning, GPS signal.
Since 2007, China and the United States have proven they're capable of destroying satellites in low Earth orbit with missiles. They've each taken out one of their own satellites. It's no easy feat, since the satellites are streaking across the sky a few hundred miles above Earth at about 17,000 miles an hour. Without fast computers, people wouldn't stand a chance.
Hitting a satellite in space with a missile is as difficult as hitting someone else's tennis serve with yours. Getting the timing, getting the speed right, it's virtually impossible. But for a modern missile with advanced technology, it's not that difficult. These missiles have sensors that allow them to determine their own location and the target location and changes and make split-second adjustments and hit them. Imagine if you had a smart tennis ball using the same kind of sensor technology, adjusting its location hundreds of times a second to make sure it hit the target.
And once a missile intercepts a satellite, a big explosion isn't needed. In fact, many anti-satellite missiles are designed to simply ram their target without any explosives at all.
Space-based materials are designed to be fairly light. It's very expensive to lift things into orbit. It takes about 100 pounds of fuel to lift 1 pound into orbit, so you want to make things as light as possible, which makes them also usually comparatively easy to knock out.
And back on Earth, the effects of an all-out space war in the next decade would be severe. If countries begin blasting each other's satellites out of the sky, the problems would quickly spread beyond making it difficult for the military to wage war.
Today's global society is definitely dependent on space. If we were to start losing satellites, not just military satellites, but commercial and civil satellites, what would happen to daily life? Suddenly, ATM machines don't work. Many cell phones don't work. Pay at the pump no longer works. Financial transactions all over the world that use the GPS timing signal all of a sudden are disrupted. So the whole world slows down.
And if a space war escalated totally out of control, missiles might carry nuclear warheads into space to make sure important targets were knocked out with a big blast. But you won't believe how different a nuclear blast in space looks, and how destructive it can still be back on Earth. There's one weapon in today's arsenals that might still be used to annihilate targets in massive space battles of the future: atomic bombs. But anyone used to seeing atomic explosions on Earth would have a hard time recognizing these blasts in space.
One of the creepy things about exploding a nuclear weapon in space is it doesn't look like anything you'd expect. Here on the planet Earth, we see this iconic mushroom cloud. But in space, with no atmosphere, there's no cloud. Instead, you have an expanding bubble of radiation, a single flash of light, like a star, very small, going supernova.
In the first few nanoseconds, high-energy gamma rays explode in all directions, along with a flash of light, followed by an expanding cloud of radiation. The shockwave that rips buildings apart on Earth is gone, since there's no atmosphere in space. But the sphere of radiation expands faster and farther than on Earth.
You can just think of almost like bullets, but they're radiation particles going out, and they will travel a long ways. Gamma rays, neutrons. They will penetrate satellites. Some go blasting right through. Others hit electronics and cause a lot of damage.
With an average-sized nuclear bomb, any satellites within a 50-mile radius will be destroyed. But an atomic blast in space wouldn't just destroy equipment.
Astronauts flying through the debris from an exploded nuclear weapon in space would be subject to extreme levels of radiation. In particular, there are gamma rays